Hello and welcome to the Unit 5 Summative Assessment Study Guide. This is for geometry, the interim assessment. Go ahead and make sure that your name, date, and class period is up on the top. And again, I am DJ Tay. Whoop, whoop. All right, so let's go ahead. Number 1 says, what 3D figure could be formed by folding the net along the lines? And some of you may say, hey, this doesn't look like any net that we've ever seen. We've always seen the nets that look like cute little tees. Yeah, cute little tees. That's what we're used to. So what I want you to notice is that for this shape, what's important is that the sides and base, that they are represented along with the top and bottom. All right, the front and back, the sides, the base. So let me show you what that will look like if it was more like what is in our picture. Okay, so here, this means that this little side will fold. And look at that. It still folds together to make a rectangular prism. A rectangular prism, which I can tell because I have these rectangular panels, these faces. Rectangular prism. All right, number 2, what 3D figure could be formed from the net shown below? And hey, I am seeing that there are 3 triangles with a triangle in the center. So these 3 triangles are going to raise and come together at a point, a vertex. So this will be, naming by its base, a triangular pyramid. All right, let's look at number 3. Naomi is making a rectangular gift box with measurements as shown below. What is the surface area of the box? So one tip that I like to give is to go ahead and label as many areas as you possibly can, so that when you are finding the area of each of these faces, you can make sure to properly, let's fix that one. You can make sure to properly have everything labeled so you can do your multiplication. So I see that these are these panels down the center. These faces are all rectangles and they are 6 by 4. So 6 times 4 is 24. So the area here is 24. And I see this one is also a 6 by 4, so 24. And again, this is a 6 by 4, which equals 24. And this is a 6 by 4, which equals 24. And now I see here, this is a 4 by 4. So this one, though it looks real rectangulish, it is indeed a square measurement-wise. So 4 times 4 is 16. All right. So now I'm going to add all of these together. So that will be your 24 plus 24 plus 24 plus 24 plus 16 plus 16 will give you a total of 108. Or you could have just said 24 times 4 and gotten your answer, and then plus your 16 times 2. All right. And so the surface area, we have to remember our units. So this will be 108 square centimeters, or centimeter squared. All right, let's look at number 4. Number 4 is a little bit harder to see, but you'll you know that on your paper, this base of this triangle here is 6 centimeters. All right. and the height of the triangle is 12 centimeters. If you'll notice here that this is a square pyramid, okay, a square pyramid. So that means that all four of these triangles have the same area. And this square, that means if this is 6 centimeters, so is this side is 6 centimeters. So I'm going to find the area of the square in the center, and it's 6 times 6. That equals 36. All right, so now it's time to find the area of one of the triangles. I know that the area of a triangle is base times height divided by 2. All right, so my base is 6 times my height of 12. That equals 72. And now I take my 72 and I divide that by 2, and that equals 36. So each of my triangles here all equal 36 square centimeters. And this doesn't happen all the time, but the base and the triangles all have the same area. That's pretty cool. Okay, so to solve this one, I could do this like pretty simply, guys. I could go ahead and make sure that I see that all of these are 36. So I can add 36 plus 36 plus 36 plus 36 plus 36. Of course I can. But what would be super easy here is just simply say 36 times 5 faces, 1, 2, 3, 4, 5, is equal to 180. And our units will be centimeters squared. All right, number 5. What is the surface area of the triangular prism? Surface area of the triangular prism. So I see that these, remember for a triangular prism, the rectangular sides are congruent and the triangle faces are congruent, okay? The base has its own thing going on. It just happens to be, in this case, the same measurements as the faces for the sides. So let's go ahead and solve this. This is a 1. This rectangle here is a 1 by 2. So 1 times 2 is 2. And that means this matching, this congruent one is also 2 square centimeters. And remember, if this side is 2, so is this side. So this is also, this base is a 1 by 2. So 1 times 2 is 2 square centimeters. So boom, that quickly I'm done with that. So now it's time to find the area of these tiny little cute triangles. I only have to find the area of one, so then I'll know the area of both. So first, my work is, I know that the base of this triangle is 1 centimeter, and the height is 0.8 centimeters, and 1 times 0.8 is 0.8. So 1 times 0.8 equals 0.8. Well, that's the base times height. Now, because it's a triangle, I have to divide by 2. 0.8 divided by 2 equals 0.4. All right, so this triangle is 0.4 and this triangle is 0.4. So now I want to add these all up together. 2 plus 2 plus 2 plus 0.4 plus 0.4. I get 6.8. So my final answer with my units is 6.8 square centimeters. That's the surface area. All right, number 6. Brian had an aquarium shaped like a rectangular prism. The edge lengths of the aquarium are given in meters as shown. What is the volume of the aquarium? All right, so we know that volume equals length times width times height. All right, length times width times height. And a tip that I give is to go ahead and label the parts on the box. Okay, so I see that this is my L, This is my width. This is my h for height. And now I'm just going to multiply these. So my length is 1/2 times my width of 1/3 times my height of 1/3. And since I'm multiplying fractions, I'm just multiplying straight across, guys. 1 times 1 is 1, times another 1 is still 1. 2 times 3 is 6, times another 3 is 18. All right, so I've multiplied these and I get 1/18, but I need to 1 over 18. What are my units? My units are meters, and because I multiplied meters times meters times meters, this is meters to the third power, meters cubed, or cubic meters. All right, number 7, an ice machine produces ice cubes that are 2/3 centimeters on each side. What is the volume in cubic centimeters of one ice cube produced by this ice machine? All right, so it just told me, and I like to tell my students that you can always draw a picture if it helps, right? Always draw a picture. It doesn't have to be perfect. Okay, so this means that if it's 2/3 centimeters on each side, this is 2/3. All right, this is 2/3, and the height is also 2/3. So that means it's a cube. So the length, width, and height each equal 2/3. So that means I am multiplying 2 over 3 times 2 over 3 times 2 over 3. And this is our multiplication of fractions. So I am multiplying straight across. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 equals 27. So my final answer is 8 over 27, 8/27ths, if you want to get fancy with it, right? Say it correctly. And this was in centimeters, and because I did volume, I multiplied centimeters times centimeters times centimeters. This is centimeters cubed, or cubic centimeters. All right, number 8. A box in the shape of a rectangular prism is shown. The box contains 1/3 inch number cubes. What is the volume of the box? So they told me that each of these cubes are 1/3 inch, but they already did the math for me. So I see that the length is 1 1/3. The width is also 1 1/3, and the height is 2 inches. Okay, length, width times height. So let's go ahead and set this up. But I noticed something. This is 1 1/3 and this is 1 1/3. In order to start my multiplication of my fractions, I need to turn these mixed numbers into improper fractions. So I have 1 1/3, and I'm going to change this. I like to call this the big C. And remember, we're going to follow this arrow. All right, so we start at the denominator of 3, and we follow it around. So 3 times 1 is 3. And then I add that answer to my numerator. 3 plus 1 is 4. So my answer is 4, and I put it back over the original denominator that I started my change with. So 1 1/3 as a mixed number becomes 4/3 as an improper fraction. So now let's do the whole length times width times height. So I have my length of 4/3 times my width of 4/3 times my height of 2 inches. And I have all fractions here, so I'm going to make that to look like a fraction as well. And then now this is just multiplying straight across. 4 times 4 is 16, right? Times 2 is 32. 3 times 3 is 9. Times 1 remains 9. So my answer is 32 over 9 as an improper fraction. But if I made this a mixed number, I would be saying 32 divided by 9. Well, how many whole nines can I get out of that 32? I can get 3 of them, because 3 times 9 is 27. And how many of those of what I have left out of that 32? I will have 5. So my answer is 3 and 5 ninths. But I have to remember my units are inches, and this was volume. So my answer is in cubic inches. So 3 and 5 ninths. All right, or 32 over 9 inches cubed. Number 9, Mackenzie has a box shaped like a rectangular prism. What is the volume of the box? Okay, let's do some labeling. Our length times our width times our height. So I'm literally going to pop into the calculator my 2.5 times 1.5 times 1. And when I pop that into the calculator, I get 3.75. And my units are feet. And this is volume. I multiplied feet times feet times feet. So this is cubic feet or feet cubed. All right, number 10. A storage box is shaped like a rectangular prism, as shown below. Jalen stored 1/4 inch cubes in the box. How many cubes are needed to completely fill the box? All right, how many cubes are needed to completely fill the box? So this one, I really like this problem because your mind starts going in these different places, like to try to figure out exactly what they're asking for. So I'm just going to look at this, and I'm going to see that on this side, they say how many cubes, right? How many cubes? I'm going to fill this whole box up. Well, on this side, I have 1, 2, 3 cubes. And on this side, I have 1, 2, 3, 4, 5 cubes represented. And then I have to think the height. Check this out. 1, 2, 3, 4. You may say, oh, it's only 4. But remember that those 4 are stacked up on 1. So it's 5. So to fill this entire box with cubes, I know that I have to find the volume of how many cubes. So 5 cubes times 3 cubes times the height of 5 cubes. My length, my width, my height. Okay? So 5 times 3 is 15. 15 times 5 is 75. So guess what, guys? How many cubes are needed to completely fill this box? 75 cubes. Okay, guys, I know that you are going to rock this test out. Have a great day.